Hello, everyone. So today's part two of system architecture development, the guideline and how to examine if the architecture is good or not. So it's in this part we are going to discuss about one is a very important part of the network, right? Network. So whenever the systems connect together, they will be sort of that they will be put the network connected together. Then we, as you know, our architecture is as a scalable. We have the distributable. Your application have to be distributable. So you still need to the network as latency. The performance is very important. So that's the reason we are going to discuss now today. So in the network, we have a very important three factors: bandwidth, of course, latency, and frequency. We cannot. When you understand the things, you can understand the point out. You can calculate those things, put together, and then think about this architecture. So examine the architecture should be better to understand um, your architecture. Then, of course, there is a network performance guideline. One is you need to utilize bandwidth, so it means whatever you have to send the big data, you need to fewer round trip should be better. Then there is a reason because it's not possible to get access to same time. Second is significant time to doing the calculation. So it's very important. Then of course, there is a possible to minimize the frequency in order to when you implementing the application, you need to carefully design UI. So it should be better to better to unnecessary track transaction will be happen then or round trip happen. So it should be better to influence the UI design. API remotely access design boundary. You need to think about those case. And then, of course, there is a distribute computings. Uh, the network reliable, latency is zero, bandwidth. That's in the distribute system, and there's some kind of policies existed. They say don't think about it. Mm, Latency is zero, bandwidth is infinite, and network is uh, reliable and reliable and secure. So it is all the time. It's don't believe the case. So you need to think about from those things happen all the time. You need to think about that when you create a network. You need to think about the latency in order to create also leverage latency. You understand where latency also data size. You have to give a little bit reasonable size based on your data package. You have to maybe give a proper size, and also you need some kind of object transfer pattern because they've already been proven or suitable most cases. Then you need to think about it. Then also sometimes you don't necessary to sometimes you need necessary to think about this serialization dataset because some of them is unnecessary or some of them been calculated. So you have to avoid so those unnecessary data so been send it over the network. Then also estimate network service request frequency. So that is happening both in the client server side, so you need to identify frequency both side. To trigger, you need to avoid because unnecessary triggers should be improve the performance network. Otherwise, your network frequency is increased. Estimate how much time users spend in each page, so it's kind of user-friendly design. You have to follow this principle. You need to participate, anticipate number of concurrent clients, and advance you need to predict that how much clients should be involved at the same time. And then this is you have to know, you have to know a better understanding the latency. I mean, there is a latency. It's not one round trip. It's not the two response and request. The two step. Actually, there is included 8 process. I mean, each section they has a process. For example, network state they needed to wait for, and then transaction they still has a little bit delay. The network stick after another thing, there's another network stick they need to wait for the request, and they will be access the request, and after then you handle the request, then come to the network step to get back, then transaction, also another transaction happened between the server there will also delay time. Then finally each step is return back the stack, then you need to get back from remove the stack then when you get the request. So as long as you didn't you didn't get the response, you needed to fulfill the stack. So there is a the case you need to think about. It's not simple just like one round trip. It should be a kind of each step has a handling process. They spend the time, so better to keep your mind in this picture. So so in this example, I mean, there is a that's one sequence diagram. There is a using the two different way. One is a first you client try to get the transaction object, they send it to give the request to component to send it to transaction object, then also transaction object need to serialize, then get back the data. So there's a 4-step actually interact with between the component. So even if there's a between the component to component and the component to transaction object and component between the client have a many kind of round trip, but how about if you directly send it to transaction object, then something you need to handle on, you just get back to one times round trip. So it would be better if you give such a a big set of unit for one request. So it should be better satisfied you. It should be decrease your accessing amount of time in the transaction. Justifying user transaction. The transaction is one of the important aspect in the data integrity, of course, also related to performance. All the time, they has in order to distribute it, they still has some kind of advanced. At the same time, you need to think about the performance. That's you need all the time. You can trade-offs between the drawback and advance. So in order to understand transaction, you need to understand how the transaction been happened, or say what kind of situation the transaction needed. That basically, when you has a concurrency access, when you has a read write and same time read only access happen same time, or other words say data reliability situation existed, you have to think about it using the transaction, because the transaction make sure it's not, they make sure this data integrity, nothing left, nothing loose. So, but there's also a simple and a complex situation existed. The complex situation is mostly happening in the distribute transaction. So there is a small many operation in the one case, one logical use case. Then you have to think about data integrity. You have to use distribute transaction. Then also at the same time you have to think about in your mind, this should be in fact the performance. Then a transaction is never a transaction performance, transaction case never been predictable, just like the multi-thread case. One thing that did look, you can think about it. So it's one resource you're trying to get it. Another transaction also happened, also trying to get this release lock, waiting to release lock. One is trying to waiting for the second objective to been return some result. So there's kind of infinite loop cycle there is waiting for each other, but never get requests. So they will be infinite loop. It's been called deadlock situation. So deadlock situation happen in the, it's bad, tragic situation, the transaction. We have to analyze and avoid such case. There's a two type of transaction: local transaction and the distributed transaction. Local transaction usually is one data source, but there's a many different way to access the connection of the access. Then distributed transaction same time is a different resource, so different resource, many sub operation, but represent the one big logical unit. So you have to, in order to keep the consistent of the logical or other word, you have to keep the data integrity. So you have to use in transaction. Impact transaction factor that there's a you need to transaction control. There is of course operational, then also contextual things. Mostly happen in right conflict, isolation level. So already commit those things. You need to when you very clear idea of the transaction, then each case same time. So it should be you have a chance to leverage. So before that, you need to make a decision what kind of transaction, or whether you need to use transaction or not, because using the transaction, in fact, the performance, then also in fact the scalability. So you need to this is very critical to decide. Same time, they make sure there's data integrity, right? In other side. So first we have very familiar with your use case. You know the each details. Then identify this case. Where is a read write case happen of concurrency, whatever. Sometimes even trying to improve the performance, you use the cache. So whether the cache has a problem with transaction, you need to think about it. If there is a problem, then maybe cache is useless. So it's kind of utilizing process is useless. So that's things you need to think about before then you need to prepare the transaction. Analyzing the application transaction requirement. You needed to analyze the transaction scope. So you need to think about it. Long transactions with minimum. So it means you long transaction is mostly included. Long. I mean, much of things. So try to use long transaction, but also try. You have to say whether you need to. I mean, ACID test been passed it, then you can think about transaction. You have to use transaction. Then you also a short transaction you can use it by the sequence, so should be avoid the long transaction. Then you have a chance to all control the each step. You have a better control the each process. And then also there's of course when you manually, I mean, manually it means that when you the transaction controlled by the the logical creator, for example, as a software engineer, if they controlled it, has a problem that it's made a logical problem. Um, Possible to not a good transaction solution. I mean, there's a not, if not well skilled, good skilled the engineer been apply good knowledge, then transaction still have a transaction problem. So there's a chance that you can use container managed transaction. Usually, container managed transaction provided by products kind of application server. Then you just needed to understand without using any kind of transaction when you're writing the program. So after then, some of the well understand engineer just focused on transaction, then just try to, I mean, focused on the just only case of transaction, then trying to give a control by the container level. So it's containers mostly been already tested. It's more safe and more reliable, but it's not all the time useful. So it is some people's less experienced transaction better to use container managed transaction. If there's a when you're trying to improve the performance, I think you have to control yourself by the programmer or software engineer or designer. And creating transaction identified, source. So and each resource. So you have to think about it when we need to start. Then each how many operation. Then when we needed to what kind of situation not necessary. So it's a little bit abstracted handling process. You very understand not only technique, you also understand the use case of your business. So when you're planning the system capacity, so transaction is one important things you have to think about system load, the transaction rate, number of concurrent requests, request or response time, utilization allowance. So those things you need to think about it. So there's a transaction load, how much transaction load. So in order to estimate transaction load, you need to first of all how many maximal requests are being processed in each of the unit. You can first of all you just think about how many, maybe it's 1,000 times. Then inside of the total request, how much request needed to transaction. Then whether we needed to. So it means you don't necessarily use all the requests have to be using transaction solution, because they will be slow. Your request performance will slow down. You have to avoid transaction if you're not that. The data integrity, data integrity is very important. Data reliability very important, and is one is that transaction. Make sure it's data integrity. So that's the reason you have to think about same time which one is needed, which one is not. Then transaction rate also is you have to understand transaction is kind of average of transaction happened in 1 unit of period of time. So you need to think about that. You need to do kind of test and statically which one is better from the which range to which range. Then also you need to better to test the maximum transaction in your test analyze. So peak value you have to point out, then you have a better understanding transaction scope. Then estimate client load, so it means request. So you need to also need to think about number of incoming requests must be processed, number of requests currently being processed, so in single unit. So this is a better way to understand how much average, average request. And you need to first satisfy the request, and after then you can come out to non-functional requirement like data reliability and then performance same time. Then you need to leverage whether you need to which part even use transaction or not. So mostly there is a several principles: 70% CPU utilization rule and 90% utilization rule. What does means that 70% is kind of acceptable, but it's kind of it's more secure, but it's give an alert of you have to be careful after that. And 9% is very critical, so it's almost possible to, if you get to such a level, you have to avoid because it's a little bit possible to crash your system in the 90% of, but still have a 10%. But before then, some case must be happen. Your CPUs being freezed. You cannot CPU cannot out of the maximum overload of time or handled of the critical value, so you have no chance to average. So when you're testing stage, while you're testing stage, you have to think about the two case. Then you have to think. You also simulate this 70% CPU utilization case and 90% utilization case. Then you have a more confident strategy. You will be provided to user, and also same time you can demonstrate in your stakeholder body. Then so planning the size of system, and same time thinking about the scalability. You need to think about what's the customer expectation, what's the market condition, so what's the growth of your expectation or desire. So one that user loads, and whereas response time, they are using the different kind of machine has a different kind of curve. It's the last one, and there's a small dash dot of the curve is better, provide a better performance whenever the user some case, and at the some case as second one is some case, and the first one is better performance, but finally when you have a great of user load, so still have a faster response time. So you do kind of estimate the growth rate, also think about there is a market, what kind of server application hardware provider, so your match your user expectation, then you can try to provide the best solution. So that's end of the lesson. I will leave time to ask your question.